Our brains are finely tuned machines. Inside, cells called neurons are constantly communicating to shape how we think, feel, and act. Let's eavesdrop on their conversation. These are the ends of two neurons. The one on the right sends a message, and the one on the left receives it. At first, they look connected, but they are actually separated by a tiny space called a synapse, where messages are relayed. What we'll see next is how we normally experience pleasure. The sending neuron contains dopamine, the brain's pleasure chemical. When something good happens to us, this feel-good chemical is released into the synapse, where it connects with receptors. There, dopamine activates the receiving neuron, which in turn conveys the message onto the next neuron, creating a chain reaction that produces pleasure. After the message is sent, dopamine is recycled by transporters to be reused. This conversation repeating itself again and again gives us the feeling of pleasure. How does meth change our brain? When we use meth, it enters the bloodstream and travels to the reward center of the brain, where it invades the sending neuron. Meth causes dopamine to unnaturally leak into the neuron, then spill into the synapse. Making matters worse, meth blocks the transporters, which recycle dopamine back into the sending neuron. This keeps levels abnormally high, overstimulating our brains. We feel a powerful wave of pleasure. The rush can last 8 to 12 hours from just one dose. Meth causes dopamine to flood our receptors. When we stay up, taking more and more meth, we exhaust our dopamine supply. When the regular dose doesn't give us the same rush, we take more. But now when meth reaches the brain, it finds a lot less dopamine. Plus, meth has destroyed transporters. And on the receiving neuron, all that overstimulation we loved has caused receptors to withdraw. So it's just harder to get high. No matter how much meth we use, we can never recapture that first